Hello folks, hope everyone's doing well. For section 14.2, since it's heavily math based, I'm going to split into two sections. This is the first part out of the two. So please note that the word solute is the smaller quantity in a mixture, and the solution is the total of all the different parts combined. So for example, if I have a teaspoon of salt in a glass of water, the salt would be the solute, the water is the solvent from 14.1, and the salt water is the solution, which is the total. So percent by mass is mass of the part divided by mass of the whole times 100. Percent by volume is basically the same thing as the volume of the small part divided by the volume of the total mixture, aka the solution, times 100, because it's percent. The main concentration that people use often in real life, whether you're a chemist working for 3M, a medical company to make vaccine, a company that makes household cleaning solution, is going to be molarity. This is the one you want to really focus on, okay? So I'm going to do some example from those three equations for today. We'll do the rest of it later on tomorrow or the day after tomorrow, depending on our schedule for online. So for this one, I'm looking for what is the mass of the solute. I'm giving the mass total of the solution, and I have the percent right here. Obviously, you see the word mass, you see another mass, which is gram, and you see percent is going to be percent by mass. And what am I going to try to find? I'm trying to find the mass of the solute, so I want to get that by itself. I can rearrange the equation first, or I can plug it in and then solve it to get it by itself. I'm going to do it both ways. So for this one, I'm going to rearrange the equation first. I want to get rid of this 100. Since it's being multiplied by, I divide by itself. But what if I do on one side, I have to do to the other side. Next, I want to get rid of the mass of the solution. And since that's being divided by, I multiply by the top. And that cancels out, but whatever I do on one side, I have to do on the other side. Sorry for the messy work, but afterward, all I have is mass of solute by itself equal the mass of solution on the top times the percent by mass divided by 100. And so all we have to do is plug it in now, since we have what we're looking for by itself. And the mass of solution was 350 grams. The percent by mass was 13.81%. And then the 100 had no unit in it. So when you punch it out, your answer should be roughly about 48.3 gram. And that makes sense because you're looking for mass. The only unit left over is gram, which is a representation of mass. For this one, we see the word volume and we see the percent by volume. So obviously, you know, you're looking for percent by volume because it literally tells you percent by volume in there. And you have the volume of the solute, or in this case, isopropyl alcohol is the volume of the solvent. So this is something tricky we have to watch out for. Okay, so that's the solvent, just something to note. So now we're going to write down the equation, percent by volume. And volume of solution, once again, solution is solute plus volume of solution, of solvent, I'm sorry, times 100. So instead of the word solution here, because the problem is giving me both solute and solvent, I substitute the word solvent plus solute for the word solution. So in this case, I'm going to try to do it the other way. Instead of rearranging the equation first, I'm just going to plug it in and see what I got. I got 20.101%. equal the volume of the solute, which I know is, in this case, X. The volume of the solute, I don't know either. It's going to be X. And the volume of the solvent, which is the isopropyl alcohol, is 180.2 milliliter. And of course, it's times by 100. So to get rid of 100, I divide by itself again. So now I have two fractions, and we're learning math that you can cross multiply. And this is just a distribution, X times 20.1 equal, 20.01 plus 180 times 20.1. I'm guessing 3,600 something. And since that one had milliliter in it, we put down milliliter. So now I want to combine the likes term. In this case, both of the like term has X in it. So I minus 20.01 X on this side to get rid of it. And whatever I do on one side, I do onto the other side. So when I do that, I get 79.99X equal 3605. And to get X, I divide both sides by 79.9 to get rid of it. And once again, whatever I do on one side, I do onto the other side. This gives me the solute, which is X, is equal to 45.08 milliliter. But please note that's not the answer, because the solution is solute plus solvent, which is 45.08, plus the solvent, which we were given 180.2 ml. Molarity, even though it sounds very complicated, it could be simple in some cases, and in some cases it's more complicated. Please note that molarity, which is capital M, is mole of solute divided by liter of solution. With this chapter, make sure you watch the vocabulary in the equation very, very carefully. One other thing I want to note is 1,000 milliliter is equal to 1 liter. So this is given to us in milliliter. We need to change it to liter. So on the side, I notice 4,300 milliliter, which if I move the decimal 1, 2, 3, I get 4.3 liter. Okay. So now I can just plug it in and try and punch it out. Or I can try to rearrange the equation first. Since I'm looking for molarity, which is already by itself, I don't have to rearrange anything. I just plug it in and punch it out. So the mole is 5.94 mole divided by 4.300 liter. And capital M, which is molarity, is equal to 1.38. Capital M, which stands for mole over liter. So please know that capital M stands for mole over liter, as we will see in a little bit. So you can write it as 1.38 capital M, or we can write it as 1.38 mole over liter. On this problem, we're looking for a volume. We're given the molarity because it's capital M. You see capital M, it's going to be molarity, or it's going to be related to molarity. And you see the mole of solute given to you here. So once again, capital M is mole of solute over liter of solution. This is a simple equation, so I can probably just plug it in and then trying to get what I'm trying to find by itself. Okay, so capital M is 2.80 capital M, which once again I'm going to substitute as mole over liter. Whenever you do any calculation, capital M should be plugged in as mole over liter, so it can cancel out unit. The mole of solute, which is 4.50 mole over liter of solution, which I don't know, let's call that X. So I can cancel out mole. The only unit I have left is liter, which makes sense because I'm looking for volume. So now how do I get x by itself, right? I can put a 1 underneath here and cross multiply. I get 4.50 liter equal 2.80x. And to get x by itself, I divide both sides by 2.80. And so now I have x by itself, and I grab my calculator. I punch out 4.50 divided by 2.8, and I get 1.607 liter. Or 1.61 if you're doing proper fig. And that's it. Hopefully that helps a little bit. I'll upload a worksheet with this too. Try to do it using my example. And I'll upload the answer key for it tomorrow evening.